within this project, these are the main things you're supposed to do on this left side, on the left side bar. So, okay, we have the introduction, which is basically these people talking here. And then we are going to generate an ERD, entity relationship diagram, integrating the reports, linking records, and gathering evidence, and then we'll be done. So I want to try as much as possible to um, go through this very fast. I'm not going to read all these. This is just a letter, but there's this particular file that you're supposed to download the auditor's report. It's a CSV file, so we're going to download it, and there are instructions ahead on what you're supposed to do with it and how you're supposed to go about it. So if you haven't downloaded these, basically you'll have to download it so that you'll be able to answer some of the questions down here, because I believe we're going to use this a lot within this particular project. So you need to have that downloaded. So to download, you just click on it. So when you click on it, it will basically there's this zip folder that will pop up. So you need to click on the download button. So my download button is here because of the browser that I'm using in this case. So it depends with the browser you're using. And then also if you're signed in, I think the download button will appear on the right side or something. So it's a zip file, and within it there are two particular files that have been zipped. So we have the CSV file, which is the main file we will be working with, and then we also have a PDF file, which is basically which talks about the data dictionary auditor report. It basically refers to this particular CSV file that you'll be downloading. So ensure that is downloaded. So after downloading that, we are not going to read that. So the first part of this particular project is basically to understand an ERD diagram. So we are going to generate an ERD diagram and get to understand how it works and all the other things. Basically, an entity relationship diagram is just a diagram that maps or shows how tables are interconnected within your database. So we have a database, which is like the main house, and then within the database, we have tables. Tables are also called relations. So that is why we refer to this as entity relationship diagram. And the reason why, when you are basically learning about databases, they say tables are referred to as relations, it's because within one database, yes, you can have one table, but the bigger the project, the more tables you're going to need to have. So, and these tables, they will need to relate to one another. So I believe you've read about entity relationships through the contents for this week. If not, then of course you'll need to go through it again. So ERD, so let's start. So to integrate the auditor's report, we need to access many of the tables in the database. So it's important to understand the database structure. And to do this, we really need to understand the relationships first, so we know where to pull information from. So get the ERD for the MD Water Services database and spend a few minutes looking at the diagram. Note that the visits table is the central table. Location ID, source ID, and assigned employee ID are primary keys in their respective tables, but are all foreign keys in visits. These are mostly, okay, I believe this is supposed to be one. So these are mostly one-to-many relationships. Okay, so let's generate an ERD diagram for our database here, and basically get to understand, because there's something that's saying here that visits table is the central table. So I think when you start visualization, you're going to learn something called star schema. So star schema is basically just like the shape of a star. So we have the center and then we have the edges that protrudes outside. So when you talk about a star schema, we have a central table. So in this case, when we say visits the central table, so visits table sits at the center of the schema of the star schema, and then the edges are the tables that link or interconnect or have relationships with the visits table. Okay, so it means even if two tables are not connected, the tables that are on the edges, if they're not connected, you can connect them via the visits table. All right. So let's draw an ERD diagram and get to understand what we're talking about here. So, of course, we are using the MD Water Services database. Now, to draw an entity relationship diagram, well, you are not actually drawing it because on my SQL workbench, you can just generate it. So to generate it, you come to the database here. So when you click on database, and then there's this, what is this thing called? Pop-up, I don't know. So on this particular pop-up, we'll call it pop-up in this case because I don't know how it's referred to. You click on reverse engineer. So when you click on reverse engineer, here we don't change anything. Okay, so we just click next. Again, you click next. Then you select the schema or the database that you want to view. So we are working with the MD Water Services. So we are going to click on MD Water Services and then click next. Again, click next. We execute. So once that is executed, next and finish. So we have this diagram here. So this is the diagram of how of the tables that we have within this particular schema or database and the relationships. So for example, we have the employee table. So when you hover over a table, it shows the other table which is connected to that particular table and the kind of relationship. So this line here is the relationship. Now, when you look at these lines, for example, we are referring to employee and visits table. So, okay, first of all, they said visits table is the central table. So you can see visits table is connected to almost all of the tables here. It's connected to employee, it's connected to water source, it's also connected to water quality and location. All right, so visits table is the central table, and then all these others are the on the star, the edge, right? And then this line here, the dotted lines, this is what defines the relationship. Okay, so for example, visits table to employee, you can see when you look at where it's starting here, you can see that it has I don't know what to refer to this. There's this particular part here that it's not just one route that is coming from visits, but there are three. Okay, so there are three, so it means this is many. Okay, and remember they said something that most of the relationships are one to many. Okay, most of the relationships are one to many. So from here, when you look at this particular section, there's one line here, and then on this other end there are two lines. Okay, so it means this is one to many, like that. And then also when you hover on this line, the line that defines the relationship, we have some keys that are highlighted on the tables. Okay, in this case, on the employee table, we have the assigned employee ID, and then on the visits table also is the assigned employee ID. So I believe you've learned about keys, that is primary keys, foreign keys, composite keys, and all that. So primary keys are the unique identifiers. Foreign keys are used to connect tables, right? So for instance, in this case, on the employees table, assigned employee ID is the primary key, okay? And you can see it's indicated on this table here. You can see assigned employee ID as some I don't know if this is the yellow or I don't know what color this is. I'm poor with colors, but you can see the keys indicated. So this is actually a shape of a key. So it means that's the primary key within that table. But then when you come to the visits table, assigned employee ID is a foreign key. So we are using it to connect to the employees table. Same to maybe if you check at locations and visits table again. So location ID on the locations table is the primary key, but on the visits table, it's a foreign key. Well pollution is not connected to anything. Oh no, this is well pollution copy. This is a copy that I made, but I did not delete. So, but well pollution here, you can see it's connected to location. All right. So well pollution, we have source ID. Okay, there is something here that I think, yeah. So let me just arrange them because so that you can have a better look at it. Mm. Yeah, I think this is okay now. So we have these tables here that are not connected to anything. So now here is the visits table. You can see it's connected to almost all the tables except well pollution table, right? So we are on well pollution. Yeah, well pollution is connected to the water source, and then water source, the source ID is the primary key, but source ID in the well pollution table is actually a foreign key. So that's how you basically map and understand relationships. The work of ERD is basically to help you understand relationships within your tables. If you are a database developer, somebody comes to you, they want you to uh, build for them a database, basically based on the project they're working on. For you to be able to build that database, you must have understanding of the relationships. So you're going to have, let's say, maybe it's a registration system. You're going to have users. Um, if it's a bank, you're going to have users. They are going to have user ID, maybe the name and all the other details. You also have account or bank account, which will have account ID and all that. So these things need to be interconnected. They must have relationships, right? So this here in this case will be able to help you come up with a design for whatever it is you're trying to build. Okay. So the visits table logs all the times you've been to different places, and you can see that some locations have been visited multiple times. On the other hand, the locations table has all the specifics about each place we've been, but it only includes each location once. So it's a one-to-many relationship. For each unique location in the location table, there might be many corresponding records in the visits table detailing all the different times we went there. Let's look at the relationship between visits. So these ones, I think you can look them by yourself. Basically, once you've drawn the entity relationship diagram, you can always read through these to get a better understanding of the relationships within the tables. Uh, this does not, okay, I think we need to do something here. So let's just read this. So let's look at the relationship between visits and water quality tables. For each entry in the visits table, there should be one unique corresponding record in the water quality table. This means each visit recorded is associated with a specific water quality score, ensuring one-to-one relationship between the visits and the water quality tables. But if we look at the ERD, it shows many one relationship. This does not agree with our thinking. Errors like this can cause problems, so let's fix that. So you need to fix the relationship between visits and water quality table. visits and water quality. Where's water quality? Oh, visits and water quality. So from visits to water quality, it shows many to one. Many to one. You can see at the visits here it's two, and then here it's one. So it means it's many to one. So they're saying we're supposed to fix this. It's supposed uh to be one to one. So to fix this, you right click on this particular line, the line that shows relationships, and then click edit relationship. So when you click edit relationship, we have this pop-up. When you click on foreign key here, you can see the cardinalities have been defined here, right? So we need to change this to be one to one. So after changing it, you can just close this and you're good to go. Now you can see on the water quality, there are not those many, I don't know how to refer to these things that looks like an arrowhead or something, but now it's fixed. So that is okay. Um, we should normally be careful making a change like this. First, you should check that record ID is unique for both tables and are indeed one to one. I did that, so all we have to do is right click on the relationship line and select edit relationship. Then at the bottom, select foreign key tab and change cardinality to one to one. Now the relationship line should indicate one to one relations. So I think that's what we have done. So we are good to continue. Okay, so I think that's that on exploring the ERD. Of course, we have not done much, but you can always do it when you're free just to get a better understanding. Okay. So the next section is integrating the reports. So we need basically they're saying adding the auditor reports to our data, to our database. So we are supposed to add the auditor reports. We remember this CSV file here, this CSV file here. So let's go through the instructions and see what we're supposed to do. Okay, I sent you a CSV file of the auditor's result. You should get it loaded into SQL. You'll have to think back to the start of our journey on how to do that. To make sure we have the same names, use this query to create the table first, then import the CSV file. So we have this query that we're supposed to use to, basically this is a query for creating a table. Okay, so drop table if exists, auditor report. So this basically means if this table called auditor report already exists in the database, we want to delete it and then we create it afresh. So it's going to have these columns. We have location ID, which is a variable character which says 32, type of water source, true water source score, which is an integer, and statements. So we can just copy these and then we go and run it. So it has run successfully. Let's see, tables. Okay, let's refresh. Yes, you can see the auditor report table has been created here with all the columns, location ID, type of water source, true water source score, and statements. So we have done this. So okay, got it. Good. Looking at the table and data dictionary SMT, you can see the types of info we have. So we need to create this table. Currently, the table is empty. So what we are supposed to do with this empty table is we need to import this CSV file and then add it to this table. Okay. So let's do that. Actually, we can even confirm by saying maybe select all from auditor reports. So if you run this, you can see it's actually empty, right? So since it's empty, let's bring it. So to load this CSV file into this particular table, you right click on the database name. So when you right click, we have this line here, table data import wizard. So you click on that, and then we specify where the CSV file is located. So I had downloaded that CSV file. I think Elma sent it to me or something. Did I download it really? Okay, let me check if I actually downloaded it. I think I did download it. Okay, I downloaded it, but it's still zipped, so I need to unzip it. So let's extract all. Yeah, so once extracted, we have the auditor report here. You can see type here is comma separated value. So that is CSV, comma separated values. Okay, so we are good to go. I think now we can now import it. So again, right click on that table data import wizard, and then we browse the path, downloads auditor report, and then click on these, open. Then you click next. Now select destination table and additional options. Now we don't want to create a new table. We already have the table called auditor report, right? And you can see Workbench is smart enough to highlight that we already have a table called MD Water Services auditor report, right? So you just click use existing table. Okay. If you click on create new table, it's going to create a new table, and you can see the name of this table is auditor report with a capital A. The table we created was small a. So click on that and click next. Uh, Here you just confirm if everything is right. You confirm the location ID, type of water source, and all that. If everything is correct, you click again on next, and then we click next to execute. So you're gonna have to wait for it to import the data. Basically, it's transferring the CSV data into the into our table which we had created here. So I believe this should not take time. Okay, good. Click next. You can see 1620 records imported. So this table has 1620 rows. So click finish, and then now if we run this command, now you can see our table here now has data. You can see we have location ID, we have type of water source, true water source score, and then statement. Okay, so I think that is done. Let's continue. So it looks like we have 1620 records. Yeah, that's what we got. All sites that they revisited. I see location ID, type of water source at that location, and the quality score of the water source. That is now independently measured. Our auditor also investigated each site bit by speaking to a few locals. The statements are also captured in these results. Okay, so I think now I've understood this. So basically, the auditor report is a table that contains statements that basically it's the auditors who recorded this. So what it means is that we have employees or surveyors who went and recorded maybe the time in queue for different water sources. So the work of the auditors is just to go and confirm and check if what the surveyors did is the correct thing, right? So that is basically what this table is going to help us with. So their statements are also captured in the results. So we need to tackle a couple of questions here. Is there a difference in the scores? And then if so, are there patterns? So for the first question, we'll have to compare the quality score in water quality table to the auditor score. The auditor report table used location ID, but the quality score table only has record ID we can use. the visits table, link location ID and record ID. So you can link the auditor report table and water quality using the visits table. So first grab the location ID through water source score column from the auditor report, which is like that. And then join the visits table to the auditor report table. Make sure to grab subjective quality score, record ID, and location. Um, so it gets something like this. And then note that I specified from which table each selected column is from in this query. Oh, okay, so they have provided the first part of the query already from what I'm seeing here, because I believe we are supposed to connect, we want to connect, is that part? We want to connect the water qualities table with the auditor's report so that we can compare the values that the surveyors entered versus what the auditors got, right? From this, we are able to tell whether the surveyors recorded the correct values or some recorded correct values, other recorded wrong values, right? So we are connecting these two tables, but remember these tables are not related in one way or the other. They are not related, okay? Because here they are saying the auditor report table used location ID, but the quality scores table only has a record ID, right? So there's no relationship. There's no common column that you can use to link these two tables, right? But these two columns are the location ID, which is in the auditor's report, and the record ID, which is in the water quality table. They are both found in the visits table, right? So it means we want to connect these two tables using the visits table, right? Now you understand why they said visits table is like the central table, okay? So visits table links location ID and record ID. So we can link the auditor report table and water quality using the visits table, okay? So they have provided the first section of the query here. You see they are picking the location ID from the auditor's report. They're also picking the true water source score, again from the auditor's report. And then they are connecting it on location ID. You can see they are also picking location ID and then record ID. All these are being picked. These two are being picked from the visits table. Okay, and then you can see join visits. We are joining it to the visits table. So it means we are joining the auditor report table to the visits table on these columns. Location ID within the auditor's report table is the same as location ID in the visits table. So this is the first part of the query, because remember we are supposed to connect the auditor's report and water quality. So what you basically do, it's like you are traveling. We want to travel from the auditor's report table to the water quality table, but there's no direct route. So we have to go through the visits table, right? That's, I think, is a better way of understanding it. So let's copy this, and then we have the remaining section of the synth of the code. Um, Now that we have the record ID for each location, our next step is to retrieve the corresponding scores from water quality table. We are particularly interested in the subjective quality score. To do this, we'll join the visits table and the water quality table using the record IDs as the connecting key. So this should be the entire table after it has been connected. We have the auditor location, audit location, which was basically the location ID within the audits table, through water source score, which is this. We have visit location, which is this. We have record ID also, which is this. And then we are going to get the subjective quality score from the water quality score table. Okay. So let me copy these and then add the remaining syntax. So it's supposed to be here. So we've joined the first table. Now we need to join the second table. So we'll say join, and then we want to join water quality. We're joining water quality on. So let's see, I've forgotten the column name. Was it record ID? Mm, visits table, record ID, and then water quality. Yeah. Okay, so we are joining water quality table, and then we are joining it on you can say visits dot record ID equals to water quality dot record ID. Yeah. So let's run these. Correct. So we have these here. So we have the audit location, true water source, visit location, and record ID. Hmm, Let me just make it a bit visible. Yeah, I think this is better. It's better. So we have audit, true water source, visit location, record ID 1, 2, 3, 4. We have 4 columns. I've forgotten one more column. You're supposed to add subjective quality score. You're supposed to add subjective water quality score. So subjective quality score. So you're supposed to add one column here. So we are going to say water quality subjective. If I can get that right. Yeah. So let's run that, and yes, now you have it there. So we have this table here. So basically, we have true water source score, which you're supposed to compare with the subjective quality score. So this subjective quality score is uh, what the surveyors recorded, right? And then the true water source score is what the auditors uh, basically recorded, right? Okay, let's continue. So it doesn't matter if your columns are in different formats because we are about to clean this up a bit. Since it is a duplicate, we can drop one of the location ID columns. Let's leave record ID. Okay, so we are not going to remove record ID and rename the scores to surveyor scores and auditor scores to make it clear which scores we are looking at in the result set. So we remove one of the location IDs. Let's see. Okay, which one did he remove? Hmm. Okay, I think I'll remove visit location because we remove these. And then what was the next instruction? The next instruction was okay, so we are leaving record ID and rename scores to surveyor score and auditor score to make it clear which score we're looking at. So we also need to rename these scores. So we have two water source score, and then we also have subjective quality score. So subjective quality score was what the surveyors recorded. So we are going to call this surveyor, that the spelling of surveyor, surveyor score, and then true water source score as auditor score, like that. So when we run these, we get that. How did it change? So I think this one he also changed the name to, maybe what did he change the name to? Location ID. So we have location ID, record ID, auditor score, surveyor score. Maybe this one we can change it to location ID. So location ID, and then we have record ID. Let's arrange it the way he has arranged it so that you don't get confused. So record location ID, record ID, auditor score, surveyor score, like that. Yeah, so we have these. So we have that. We can see the location ID that was recorded, the record ID, and then what the auditors recorded, and also what the surveyors recorded. All right. Okay, that's what we have. That is what we have there. Now, since you are joining 1620 rows of data, we want to keep track of the number of rows we get each time we run a query. We can either set the maximum number of rows we want to limit to 1,000 rows, to a larger number like 10,000, or we can force SQL to give us all of the results using the limits like that. So, okay, I think this is not that important, but basically, you can set limits here. So when you come here, you can see this is written limits to 1,000 rows. Now you can change it to 10,000 or whichever, or you can say don't limit. Okay, so that's up to you. Okay, let's analyze. A good starting point is to check if the auditors and is this an employees or employees? A good starting point is to check if the auditors and employees scores agree. Okay, there are many ways to do this. We can have a where clause and check if surveyor score is equal to auditor score, or we can subtract the two scores and check if the result is 0. Okay, you try and figure this one out. If you run into an error, remember that you can't use aliases in where clause. Okay, so you have to use the same name as in the select part, like this. So like that. Okay. You got 2505 rows, right? Okay. So what they want us to do here is now we're starting to investigate these records here. Remember, we have what the auditors recorded, and we have what the surveyors recorded, right? To some extent, we can believe what the auditors recorded because the auditors, what they came to do is to confirm if whatever the surveyors have recorded is the correct thing. Okay, and then they are seeing here that we can do this either using a where clause. Okay, so you have to use the same name as in the select parts like this. So okay, so let me think. Hmm, so we want to check if the surveyor score, basically what we want to check if what the surveyors recorded, what the auditors recorded match, and then basically I think we can uh, we can count the rows to actually confirm, because I see on the slides here we're supposed to get 2,505 rows. right? Okay, so we have this particular table. We need to add a query that confirms if what the auditors recorded and what surveyors recorded are matching. So I think, um, hmm, okay. So what we're going to do, I think we just need to add a where clause here because basically we need this same query to generate this table. Okay, but now we want to filter only those rows where the audit score and the surveyor score actually match. So we're going to add a where clause here. And then there's a warning we have been told. We have been told that you cannot add an alias in a where clause. Alias is this, for example, here location ID or auditor score. So every time, remember this is a column that was coming from the auditor's report. So this name is long, true water source score. And also when you say true water source score, you can't tell if it's the surveyor who recorded it or the auditor. So we have to give it another name. So that is why we gave it this name, alias, or you can call it AKA. Okay. So you cannot use an alias in a where clause, right? So it means every time you want to refer to this column, you have to basically call the table name and also the column name like this, right? So we want to add a where clause. We are going to say where the true water source score is the same as the subjective quality score. Basically meaning where the auditor score is the same as or is equal to the surveyor score. Okay. So here we just add where so where these I don't know if I can copy the all of it. So where this is equal to this. So I have to actually specify the table names because yeah, like this. So we run these. Yes. Now you can see what we actually get here. You can see everything matches. If you check at the auditor score and the surveyor score, everything matches. The first row here, you can see it's 113300 like that. Everything is actually matching, right? Okay, now let's go back to the. So you got 2505 rows, right? Some of the locations were visited multiple times, so these records are duplicated here. To fix it, we set visits.visit count equals to 1 in the where clause. Make sure you reference the alias you used for the visits in the join. Okay, so I think let's first of all let's confirm first if actually the rows we get is 2,505. So okay, let me comment this now. I'm coming back to it. So we want to count. So we can write select. Let's count all. Okay, I think maybe you can call it matching scores. Matching scores from auditor reports. Okay, I think join visits on supposed to be auditor report dot location ID. It was location ID, right? Alter recorded location ID equal visits dot location ID, and then we join the second table, which was water quality. Water quality. So water quality, I think we joined it on record ID. Is it record? Yeah, record ID. So on visits dot record ID equals water quality dot record ID. And then let's add the where. So what was our where clause? So I think I can just add it here. So where this, yeah, I think this should give us the count. Yeah. So the count is 2505. You can see from there the count is 2505. So that means we are okay up to that point. There's something they said here. Okay, so our count is 2505, so that's right. Now, some of the locations were visited multiple times, so the records are duplicated here. To fix it, we set visits to visit count equals to 1 in the where clause. Make sure you reference the alias you used in the join. So we want to add where visit count equals to 1. Basically, we are adding it in the where clause. So okay, let me try and get more instructions. So with the duplicates removed, I now get 1518. Okay, so let's first of all add that, probably put it here. So it means here we are going to add ends and visits dot visit count equals 1. So that should give us the correct number of rows. Now let's count and confirm, because now the number of rows is supposed to actually reduce if we were to count the number of rows. Remember initially with this one here, we got the number of rows to be 2505. So if we filter it to where visit count equals to 1, we're supposed to get 1518. Okay, yeah, that's correct. That's correct. So I think up to that point we are still okay. We set visit or visit count to that one. With the duplicates removed, I now get 1518. So if you filter it without the duplicates, you get 1518. So what does this mean, considering the auditors visited 1,620 sites? So if you find the percentage, you can actually confirm from, okay, we've seen it here, that the accuracy is 94%. So it means 94% of the records are actually correct, meaning 94% of what the surveyors recorded is correct compared to what the auditors recorded. But that means 102 records are incorrect. So let's look at those. So we have 102. Basically, if you subtract the 1620 from 1518, you get 102. So there are these 102 which are not correct. So we want to scrutinize these ones and understand why they are not correct. Okay. Um, you can do it by adding one character in the last query. Oh, so they want us to actually try and they want us to try and retrieve those columns or records where which are not correct. So, for instance, if you look at this, the table that this person gets, you can see the auditor score here for this particular one is 3, and then the surveyor score is 10. So these ones are not correct. Okay. Okay. So let's first of all get or have a look at these ones that are not correct. So we can bring this one aside. Now, how do we get these rows that are not correct? We can add visit count is not equal to 1. So this is not equal to, or you can do it like this. Okay. So if we run these, wait, whatever is done. Um, you can add it by adding one character in the last query. Look at what I've done. But this is supposed to be there. Let me think. I'm a bit confused. It's not there. It's not here. Yeah. So to get those ones that are not correct, the 102, you can actually add an exclamation mark before the equal sign, or we can do it like this. So when you do it like this, though I think this one is not working here. So this one also means not equal to. I wonder why it's not working. Oh, why was it bringing a syntax error? Yeah, so if you run that one also, you still get the same thing. So you can see these ones, the auditor's score and the surveyor score are not the same. They are uh, not aligned. Okay. So I get something like that. So since we used some of this data in our previous analysis, we need to make sure those results are still valid. Now we know some of them are incorrect. We didn't use the scores that much, but we relied a lot on the type of water source. So let's check if there are any errors there. So to do this, we need to grab the type of water source column from the water source table and call it surveyor source using the source ID column to join. Also select the type of water source from the auditor report and call it auditor source. So we need to add two more columns. We have already known that there are some surveyors who did not record the correct values, all right? Because when you compare the values that they have and what the auditors have, they don't align, all right? Now we want to check also if if they recorded the correct water sources. Remember, we have a table called water source, right, which records the water source type. And then within the auditor report table, we also have the type of water source column. So this one records the type of water source as well as the type of water source in the in the water source table. They both record the type of water source. But now, the same way we compare the auditor score and the surveyor score, we also want to compare the type of water source score uh, in the water source table and also in the auditor's report. Just to confirm if at all these ones were also um, not recorded well. Okay, so we need to add type of water source from the water source table. So it means we are going to join again the water source table here. Okay, let me see how he has arranged his. So auditor source is coming from the audit report, and then surveyor source is coming um, from the water source table, right? So that is after location ID. So after location ID, we have audit report dot is it water source or type of water source? Type of water source. Type of water source, right? So we need to have that. And then you also have surveyor source. So after these, we need to get the where's the water source table? Water source. So here we also have type of water source. Let me check the visits table if source ID. So visits table as source ID. Okay, good. So here we also have water source dot type of water source, and then we need to join it to join water source and water source dot source ID equals visits dot source ID. Yeah. Okay, good. So we have this now. Now, oh, okay, we are supposed to give this one some names. So this one was supposed to be as surveyor source. This is auditor source. And this is surveyor source. Yeah. So now we have everything here. We have the auditor source and the surveyor source. I think for the sources here, they recorded them well. I don't think there's any issue with the sources here. The sources seems okay, but anyways, let's see. So what I can see is that the types of sources look the same. So even though the scores are wrong, the integrity of the type of water source data we analyzed last time is not affected. Okay. So the water source uh, that is recorded correctly. We, however, only have problem in the scores. Okay. So once you're done, remove the columns and join statements for remove the columns and join statements for water sources again. Or we remove them. Okay. So we remove the columns and these things for water source, type of water source, because they are correct. We don't need anything with them. Yeah. Okay, so after removing, okay, now we are on to the next thing now, linking records to employees. We're on to the next one now. So basically, we've edited the auditor's report. We've realized that there are some discrepancies. We realized that actually the auditors have helped us realize that there are some surveyors who did not record the correct things. So let's see what linking records to employees will help us achieve here. So next up, let's look at where these errors may have come from. At some of the locations, employees assigned scores incorrectly, and those records ended up in this result set. Or at some locations, the employees assigned scores incorrectly. I think there are two reasons this can happen. These workers are all humans and make mistakes, or unfortunately, the alternative is that someone assigns scores incorrectly on purpose. Hmm. In other case, the employees are the source of the errors. So let's join the assigned employee ID for all the people on our list from the visits table to our query. Remember, our query shows uh, shows the 102 incorrect records. So when we join the employee data, we can see which employee made these incorrect records. Um, So we need to incorporate assigned employee ID to get the IDs of these employees who have inconsistencies in their in their what is it in their records. Okay, so I think employee IDs in assigned employee IDs in the visits table. Yes, we have the assigned employee. We have assigned employee ID. Assigned employee ID. So with this assigned employee ID, we need to add it somewhere. Let's see how these people are. It's after record ID. So after record ID, we are going to have visit.assigned employee ID. Yeah, so we're going to have visits.its assigned employee ID like that. Yes, and we have the IDs of these employees that um, that recorded their own things. Okay, they decided to record their own things. So I'm actually seeing some repetitions. For instance, this employee of ID that's four. We saw that for up here we have one, one, one. So all these are employees who did some mistakes with their records. So now we can link the incorrect records to the employees who recorded them. The IDs don't help us to identify them. We have employees' names stored along with their IDs. So let's fetch their names from the employees table instead of the IDs. So we already have the IDs. So what we need to do is to be able to get their names. Okay. Now to get these people's names, remember the assigned employee ID, we got it from the visits table. So visits table only records the employee ID, not the name. The name, however, can be found in this table called employee. So when we click on employee, we have employee name here. You can see also we have assigned employee ID and the likes. So instead of recording the employee ID, we want to have the employee name. So basically, what we're going to do here, we want to incorporate employee dot its employee name here. So employee dot employee name, and then after that, remember we now have to join employee ID. So we are joining employee ID to the visits table because these two tables have a connection on the assigned employee ID. Remember, assigned employee ID is in the employee table and it's also in the visits table. So we are going to add another join here. So we are going to say join employee on employee dot assigned employee ID. Assigned employee ID equals to visits dot that. So we run these and we have the names here. Now you can see you have all these names. So instead of um uh, uh, the ID, now we have the names. So we can see the names. We have Rudo Imani, Bello Azibo, Rudo Imani, and the likes. So those are the people who recorded their own things there. So Rudo Imani, yeah, I think we have that. So this query is massive and complex. So maybe it's a good idea to save this as a CTE. So when we do more analysis, we can just call that CTE like it was a table. Call it something like incorrect records. So you're going to call the CTE incorrect records. Once you're done, check if this query select all from incorrect records gets the same table back. Now that we've defined incorrect, we can query it like any other table. So we need to create a CTE. A CTE, I believe you've read it about it. CTE stands for uh, common table expression. Okay, so basically it's a way of you see the way this query is big. Our query here is so big. So what we can do is we can basically we can create a common table expression for it so that instead of having to write all like this, we group it also that it appears as a table. Okay, CTE just makes it appear as a table. So basically, you can query this thing the way you query a table. Instead of having to write all of these, once you make it CTE, you can query the CTE itself, not all of this. You just query the CTE the way you query a table. So to turn this into a CTE, CTE has a syntax that starts with the with keyword. So with, and then you provide the name of the CTE, and then as, and then you create a bracket. So the syntax will be like this. So you say with, and then the name. So they said we call it incorrect records, and then as, and then we have these brackets like this. So this is CTE. So inside these brackets here is where we're going to have all of this syntax for the code. So let's go cut everything. And then let's paste this here. Yeah. So we have our CTE here, and then I think they said something that um, check if this query. So basically, you can see here now we are querying the CTE. Now it appears like a table. So select all from, and then you always provide a table name. But here now instead of the table name, we are providing the CTE name. So let's test these and see if we get the same results. Oh God, incorrect records. Like that. So if we run these, we should get the same thing. And that's what we have there. So that one is done correctly. Okay, now let's first get a unique list of employees from this table. Think back to the start of your SQL journey to answer this one. I got 17 employees. So we need to get the unique employee names. Unique employee names. So it means what we're getting here, for instance, if you look at what we got here, you can see Rudo Imani is twice. So we want to know the employees. So basically, we are trying to get the unique names. So instead of the duplicates, if it's Rudo Imani is just um, going to appear just once. Okay. Now to do that, remember we now have our CTE here. You can see Workbench has actually highlighted it. You can see from here up to here. So this is where the city ends. And then down here, you can add any other query that you want. Okay. So you want to find unique employee names. So basically to do that, we just use select distinct, distinct. So distinct employee name. Remember, employee name is within the city. It's a column in our common table expression, right? So I think they just wanted the distinct employee name, the unique employee name. So from now here, we are providing the name of the CTE. Correct, incorrect records. So if you run that, we get this. Okay, we get the unique employee names. I think we can add count here to see to get the total. Yeah, 17. They said it's supposed to be 17. So we're okay up to that point. Um, think back. So you got 17 employees. Yes, so there are 17 employees. Next, let's try to calculate how many mistakes each employee made. So basically, you want to count how many times their name is in the incorrect records list and then group them by name. Okay. So we want to know how many times they made mistakes. For example, initially, before, if we use select all here, if we use select all, we get duplicates. For example, here you can see Udaimani, this is the first mistake he made. It has appeared as number one. And then we have the second one here, right? And then I believe there's another Udaimani somewhere. Okay. So we want to count how many mistakes did each and every employee make. Remember, we are not adding the mistakes. The mistakes they made are in the surveyor score. All right. These people are actually surveyors. They are the ones who are recording the surveyor score. All right. We don't want to sum the number of surveys they recorded wrongly. We want to count how many mistakes they made. All right. So that means we are going to use the count method. So okay, how does he want the table to appear? So it should have employee name, and then this column is going to be number of mistakes. So it means again we are just using the city that we created, okay? So we are going to select employee name, and then we want to use count. So we are counting, I think we can count all. You can count all as number of mistakes, and then we are selecting it from our city using incorrect records, and then we want to group by name. So group by employee name, right? So if we run these, again, we can see now we have the employee name and also the mistakes that each and every employee has made. So Rudo Imani has made 5 mistakes, Bello Azibo 26, Zuriel Matendo, like that, right? So we can see how many times these employees have recorded wrong results. Do you see a pattern? Order the list if you can't see it yet. It looks like some of our surveyors are making a lot of mistakes, while many of the other surveyors are only making a few mistakes. Okay, let's order the list. So maybe group by employee name, and then we order by number of mistakes. Order by number of mistakes. Let's order it in descending. So from the highest going to the lowest. Okay, so if we order it like this, you can see Velozibo made the highest number of mistakes, 26. Malachi Mavuso, 21. Zuriel Matembo, 17, like that. We have people who only made one mistake, so we can't punish people who have made one mistakes. But these people, you can imagine somebody just recorded 26 wrong results. So that raises questions. So it looks like that. Okay, let's continue. Okay, so we move on to the next part, which is the last part here, gathering evidence. So we want to gather evidence of these mistakes that these employees made, if I'm not wrong. Okay, so thinking about this a bit, how would we go about finding out if any of our employees are corrupt? Hmm. Let's say all employees make mistakes. If someone is corrupt, they will be making a lot of mistakes, more than average, for example. But someone could just be clumsy, so we should try to get more evidence. Our auditor did say some of the things. Our auditor did say some of the things he had on the streets were quite shady, and he recorded this in the statement column. Considering both of these sources should give us a pretty reliable answer. So we have the statement column that records some of the things that the auditors overheard on the streets. Let's try to find all of the employees who have an above average number of mistakes. Let's break it down into steps first. So number one, we have to first calculate the number of times someone's name comes up. We have done that. We already have that. It shows the number of times each and every name comes up, and we can see Bello Azibo. Bello Azibo's name is the highest. Then we need to calculate the average number of mistakes employees made. We can do that by taking the average of the previous query's result. So something like that. So we need to calculate the average number of mistakes. So basically, that means this row that records number of mistakes, we want to calculate the average of it, right? So after that, so you can do something like this. So average number of mistakes from error count. Let's call the results average error count per employee, which will be a scalar value. Finally, we have to compare each employee's error count with average error count per employee. We will call these results set our suspect list. Remember that we can't use an aggregate result anywhere, so we have to use average error count per employee as a subquery. Select employee name, number of mistakes from error count where number of mistakes is greater than average error count per employee. So what they're saying is that we already have the number of mistakes made per employee, right? So what we need to do is we need to calculate the average. So we are going to, for instance, we are going to have average mistakes. Let's say maybe average mistakes is maybe 20. And then what we are going to do is we are going to go through each and every employee and we are comparing the number of mistakes they made. Basically, we're going to take the number of mistakes they made. For instance, Belwazibo has 26 mistakes. So we're going to take 26 and then we're going to subtract from average. All right. So this is 6, right? So it means this person, this is not a mistake per se. This is something that they did intentionally. So either they are corrupt or they are lazy or whatever reason. But now this will be able to tell or will be able to help us identify which employees actually made mistakes and which employees are corrupt. All right. So let's continue reading. Um, let's start by cleaning up our code a bit. First, incorrect record is the result we'll be using for the rest of the analysis, but it makes the query a bit less readable. So let's convert it to a view. So view is like a table. View is basically a table. Okay. We can use it as if it was a table. It will make our code much simpler to read, but it comes at a cost. We can add comments to CTE in our code. So if we run to, so if we return to that query a year later, we can read those comments and quickly understand what incorrect records represent. If we save it as a view, it's not as, it is not as obvious. So we should add comments in places where we use incorrect records. So replace with the create view like this. I know that I added the statement column to this table in line 8. So okay, so they have created for us a view. They've created for us a view. Hmm. So this is how you create a view. Again, you use the keyword create view, just the way you'd create a table, and then you provide the table name. The view name, sorry, not the table name, the view name. So our view in this case is incorrect records. And then this is now the query that creates the view. Select that from that. Um, visit count is 1 and auditor report is not equal to, what is the water quality? Okay, what happened to all these instructions that they said we should be doing here? Because I'm seeing uh, same result as the CTE did. The CTE did. So you have location ID, record, employee name. Okay, I think if they provided a query, there's no need of complaining. So instead of using the CTE, we are going to use a view. which is more easier to work with. Mm. Let me arrange it so that it becomes readable. Where visit counts, let's do that. So if we run these, I believe there are no errors. Okay, no errors. So if we run this, remember we created a view, so it means we should be able to have access to this view. So when you come to this sidebar here, we should have a view. Okay, let me refresh. Oh, okay, so good. So we have the view here. So remember, guys, I've told you view is just like a table that you're creating. You can see it as all the columns. So location ID. So the columns have been specified here. The first one is location ID. You can see location ID, record ID, employee name, um, auditor score, surveyor score, and we also have statement. So, okay, that is okay. Now selecting all from incorrect record gives us the same result as the CTE. So if you select all, from incorrect records. Remember the incorrect records in this case now, it's not a CTE, but it's actually a view. Okay, it's a temporary table that we have created. Okay, why am I getting an error? Oh, already exists. I need to comment this out. Yes, yes, yes. So this is the view that we have just created. So we have again the location ID, record ID, the employee's name, uh, auditor score, surveyor score, and then we also have um, statements. Okay. Next, we convert the query error. We convert the query error we made earlier into a CTE. Test it to make sure it gives the result again using select all from incorrect records. On large queries like this, it's better to build the query and test each step because fixing errors becomes harder as the queries grow. Select employee count from incorrect, group by that. Okay, so it seems this last part we have been given queries. I'm not seeing anything to do here. So we create a CTE for errors. So these are just comments, okay? Maybe, okay, let me remove them so that they don't confuse somebody. Wait, I've removed something that I should not have removed. Yeah, group by. Okay, these comments are already causing problems. Need to group by like that. Yeah. So remember we had the same thing like this, where we had the employee's name and also the number of mistakes that they made. And initially we called it incorrect records, right? Now we've created a view that is called incorrect records. Okay. So after creating a view called incorrect records, we are again creating now the same CTE that we had, but now we are naming it as uh, error counts. Okay. Instead of incorrect records, because we've used the incorrect records word to create a view. So this is on the CTE. Basically, this is the same thing that we already had. We are creating it as a CTE. So after that, now calculate the average number of mistakes. Calculate number of, you should get a single bar. Now calculate average number of mistakes in the in the error count. So we need to now calculate average number of mistakes here. Okay, using now this one here. So I think this we can just select, then we say average of number of mistakes from error counts. So if you run this, we get 6. 6 is the average, 6.0000. So 6 is the average. And then to find the employees who made more mistakes than the average person, we need the employee's name, number of mistakes each one made, and filter the employee with an above average number of mistakes. Hint, use select average mistake count from error count as a custom filter in the where part of our query. So now we want to get the employees who actually have their number of mistakes above the average. Okay. So to do that, then take note of this hint here. They've said select average mistakes from error count. This is what we've just computed here. Select average number of mistakes from error count. Okay. Now let me write the query and then I'm going to tell you guys. So you want to select, you want to get employee name, and then you want to select you want to select count, employee name as I think here they gave it another name. It's still number of mistakes. It's number of mistakes from error count. And then where? Now we want to filter. So we are filtering where the number of mistakes, we are filtering where number of mistakes is greater than this, is greater than the average. Okay. So here, basically what we're doing here is we have not stored the average number of mistakes into a variable or something. So that is why when we want to compare it, basically what SQL will do is it's going to print the employee name. It's also, when it comes to the count, it's going to count and then it's going to run this where clause. So it's basically going to compare these things that I've counted. Is it greater than? And then when it's comparing, it's going to run this query again. Now it's going to select the average number of mistakes, and then it's going to do the comparison and then give us the correct record. So we run these. Oh, oh, quickly, let me see. Mistakes. Hmm, yes. I was supposed to have selected the column. I was wondering why is it telling me to group by, and yet we've already have that one inside the CTE. So we have the employee's name. We also have the mistakes, but these are employees whose mistakes are greater than the average uh, mistakes that we computed earlier. So you can see here we have below Zibo, uh, basically 26. Remember, average we got was 6. So the average was 6. So 26 is greater than 6, and all these other values are greater than 6. So these are the employees who made more mistakes on average than their peers. So let's have a closer look at them. We should look at the incorrect records table again and isolate all of the records these 4 employees gathered. We should also look at the statements for these records to look for patterns. Okay, so first, convert the suspect list to a CTA suspect list. All these people. So we can use it to filter the records from these 4 employees. Make sure you get the names of the 4 suspects and their mistake count, the results, using select employee name from suspect list. So we want to create another CTE. We are going to call it suspect list, and basically we are creating it from the previous CTE, this one that from this one here, this one that we have here. So this new CTE, you are going to call it suspect list. So what we can do is let's cut this. Then after cutting that, we're going to say with the suspect list as, and then we copy this one inside here. Yeah, so basically what we're doing here, we are creating another CTE called suspect list from our CTE. Our CTE initially was this one, but now this one, when we added this select here, it's going to specify employees, these particular employees down here, whose number of mistakes are greater than the average mistakes that we computed earlier. So these are the people that I think you can say that they're like the main culprits, all right? They're the main culprits because the number of mistakes they have made, uh, it's so big, right? So we are interested in trying to understand why they went to this particular extent. So we are creating a CTE for them, and then this CTE we are calling it suspects list. So these are like our suspects, right? We want to study them and get more information as to why they have these big figures on the number of mistakes they have made. So after that, if we select all from suspect list, we should get the same list. Yes, so we get the same list. So that is okay. Then you should get a column name, column of names back. So let's you should get a column of names back. So let's just recap here. We use incorrect records to find all of the records where the auditor and employee scores don't match. We then use the error count to aggregate the data and got the number of mistakes his employees made. Finally, suspect list retrieves the data of employees who make an above average number of mistakes. First, let's add the statement column. Let's add the statements column to the incorrect records view. Then pull up all of the records where the employee name is in the suspect list. Use select employee name from suspect list as a subquery inside where. Let's add the statements column to the incorrect records view. I think the statement column is in that view already. Let me just select all from incorrect view. Okay. Why is it not? It's not incorrect view. It's incorrect records. So statements column is already there. Let me understand what they are trying to say here. Add statement column to the incorrect records. Then pull up all of the records where the employee name is in the suspect list. Int, you select employee name from suspect list as a subquery. Okay. Okay, I understand. So we want to we have the list of suspects already. We have the list of suspects from our CTE here. We have the list of suspects, right? So what we want to do is we want to pull the statements. We want to get these particular column, the column for statements, from the view that we created, the view that was called incorrect records. We want to pull this column for each and every employee who is in our suspect list, right? We want to identify, remember this column, the auditor recorded what some of the things that he had on the streets, okay? So probably this might give us a clue on the corruption that has happened with these employees that are in our suspect list, okay? So what we need to do is we have this CTE for suspect list. So we are not going to tamper with it. We are going to leave it like that because we want to query it. And then here, let me see how this table looks like. So we have employee name, we have location ID, and then we have statements. Okay. So we want to select, and we are selecting employee name. We are selecting location ID, and then we are selecting is it statement or statements? Statements. So we are selecting statements. These ones we are getting from incorrect records. Incorrect records. Then we want to say where, we have to add a where clause because we want statement um, only for the employees who are in our suspect list, right? Only for the employees who are in our suspect. So you're going to say where, um, and then here we are adding another statement to select the employee. So select employee name from suspect list, like this, right? So when we run this, I think I'm having error. Ah, okay. Look at me where employee name in. Yeah, employee name in. I just added where without yes. So we get what we want. So you can see these are the names of those suspects, and then you can see Belazibo, and then we now have the statements that have been recorded here. We have Belazibo, like that, like that. Okay, let's continue. Belazibo, Zuriel Matembo, and the likes. Using this query selects, and this query filters all of the records where the corrupt employees gather data. Select from incorrect to employee in. Okay, so they already provided a section of the query. And this query is complex, right? But if we document it well, it is simpler to understand. You don't want to see what this query looks like using employee name, mistakes from that, group by that, select that where number mistakes, select employee name. So this is actually the same query that we've written, okay? So if you have a look, you will notice some alarming statements about this for officials. Look at these records. So I think you can confirm those IDs. Okay. For example, see how the word cash is used a lot in these statements. Filter the records that refers to cash. Let's just do one more check to make sure. Check if there are any other employees in the incorrect record table with statements mentioning cash that are not in our suspect list. This should be as simple as adding one word. I get an empty result, so no one except the four suspects has these allegations of bribery. Oh, okay, I understand. So they're saying, you see, we have these statements here. So these are basically what the streets are saying, what people are saying on the streets about these particular employees, all right? So what they want us to do is they want us to filter the statements here that have anything to do with the word cash. So cash basically means they're probably referring to somebody was has been bribed of something, or somebody was trying to request for bribes, or you know. So those are the things we want to look at. So if there's anything or any word to do with cash within the statements, we are able to tell which employees who are trying to request for bribes or were involved in some sort of bribery, right? So here what we can do is we're already getting these employees. So you're already getting the employee name, the location ID, and the statement. So what we need to do is to just filter this statement here for any word um, that has cash, any sentence that has the word cash in it. So basically in our where clause here, we're going to basically just say and I think statements. So you can say statements like and then we are looking for the word cash. So what this is going to do is it's going to go through each and every row, and within this particular statement, it's going to just find for the word cash either on the left or on the right, right? So if we run these, let's see if we get what we want. So for example, Zuriel Matembo here, villagers, this thing is too small. Mm, Yes, you see the mention of cash. So there's cash in here, and then if you go reference to cash, so there's cash there, allusion to cash, cash. So you can see cash is actually appearing in those statements there. So it means those people were somehow involved in some shady behaviors. Check if there are any employees in the incorrect records table with statements mentioning cash that are not in our suspect list. These should be as simple as adding one word. I get an empty result, so no one except the first suspect has these allegations of bribery. Okay, so mm, so we're basically querying employees who are in the suspect list CTE, and already we can see that there are allegations of bribery because we are finding the word cash within the statements that were said about them on the streets. How about the other employees who are not among the suspects? So they want us to also query and try and find the word cash within the statements for those employees, right? So they've said it's as simple as adding one word. So basically it means where employee name, we can just add note here. So you say not in. So if you run that, you can see it returns empty. So it means those are the employees who are not involved in some sort of bribery or whatever. Okay. But these ones, the ones that are in our suspect list, you can see the word cash appearing within their statements. So it means they were involved in some sort of shady behaviors. Um, mm, so we can sum up the evidence we have for Zuriel Matembo, Malachi. These are those employees. They all made more mistakes than their peers on average. They all have incriminating statements made against them and only them. Keep in mind that this is not decisive proof, but it's concerning enough that we should flag it. Um, oh, that's the end. Okay, I think that's the end of it. Um, from these assignments, I think the best way for you to go about this assignment is you need to read and understand about views and common table expressions.